So dear students, today we start one problem about Fourier series. Find the Fourier series corresponding to the function fx defined in -2, 2 interval as follows. Fx equal to when -2 less than equal x less than 0 and fx equal to x in 0 less than x less than 2. Now we want to find the Fourier series from this given function. Now solution, here the interval is -2, 2 and c equal to we get 2. The value of c is 2 because our original definition -c, c, this is our interval and here c equal to 2. First we have to find a naught. A naught equal to 1 by c, here given -2 to 2, so we get integration -c to c fx dx. We get this. This is c means the value of c is 2, so 1 by 2 -2 to 2 fx dx, and we know this formula a to c fx dx, this equal to a to b fx dx plus b to c fx dx. So a less than b less than c. We know this formula. This is the superhead formula. So we know this is a well-known formula. A to c fx dx equal to a to b fx dx, b to c fx dx. We adding our original limit given a to c, adding b between a and c. So b we adding, so we get this one. So here -2 to 2, our -2 to 2, then 0 is between -2 and 2, we get 0. So 1 by 2 we get -2 to 0 fx dx plus 0 to 2 fx dx. By using this formula we adding b, but here we adding 0 because 0 lies between -2 and 2 in this given problem. So 1 by 2, this is -2 to 0, so we get -2 to 0 fx, -2 to 0, then fx is 2, we get this is 2 dx, and 0 to 2 fx, 0 to 2 fx means x, so we get x dx, we get this one. So 1 by 2 remains same, minus this 2 outside, integration dx means x, so this will be -2 to 0, and x means x square by 2, this one 0 to 2, so we get this one. So 1 by 2, this is 2, and this will be 0 minus -2, putting upper limit minus lower limit, then this 2 is outside, this will be 2 square minus 0 square, we get this one. So this is 1 by 2, then this minus plus, 2 and 2 4, and this is 4, dividing by 2 we get 2, so this is 1 by 2, this is 6, this will be 3 we get. If we cancelling this, we get 3. So what we get, a naught equal to 3, we write this result here, a naught equal to 3 we get. Next we have to find an. Now an equal to 1 by c, this is -c to c fx cos n pi x by c dx. We get this -c to c fx cos n pi x by c dx. So c means 2, this is 2, we putting 2, and -2 to 2 fx cos n pi x by 2 dx. So 1 by 2, again using the superhead formula, -2 to 0 fx cos n pi x by 2 dx plus 0 to 2 fx cos n pi x by 2 dx. We putting this formula using adding 0 between 0 minus 2 to 2. So 1 by 2 minus 2 to 0 fx. Minus 2 to 0 fx means 2 we get. This is 2 cos n pi x by 2 dx 0 to 2 fx. 0 to 2 fx means x we get. So x cos n pi x by 2 dx, we get this one. So we using this by parts formula here. Again I recall the formula, it was given several videos. uv, this is u v1 minus u dash v2 plus u double dash v3 minus dot dot dot. We know this by parts formula. If we write in one line, by using this formula we get our result. So this is v1 means integration v, v2 means integration v1, v3 means integration v2, and u dash means dx of u double dash means dx of this, just like this. So using this we get 1 by 2, and this is 2 outside 2 cos mx by, this is cos mx. We know this formula. I rewriting this formula, cos mx dx, this equal to sin mx by m plus c. We know this formula. So we consider n pi by 2, this is m, cos mx. Then this will be sin n pi by 2 by n pi by 2. We get this. This is minus 2 to 0 limit. Half multiplying here also, half. Now using this formula, first u means x, v1 integration cos means sin n pi x by 2 divided by n pi by 2 cos mx sin mx by n minus u dash, that means ddx of x. ddx of x means 1, and v2 means integration this. Integration this means, integration sign means minus cos n pi x by 2 divided by n pi by 2, another n pi by 2. This is n pi by 2 whole square, you get this one. So this is our second derivative of this. This one limit is 0 to 2 we get. So we get this multiplying here, or this cancel, 2 cancel, 2 by n pi we get 2 by n pi, and putting the upper limit first 0 into something is 0, so this will be sin 0, and putting lower limit, so putting lower limit, then lower limit is minus 2, so this will be sin minus 2n pi by 2. We get this one. If we putting upper limit as 0, sin 0, and lower limit, this is x equal to 2 putting, we get this minus this. And this will be 1 by 2 remains same, and putting, again we rewriting this, minus plus, we get x sin n pi x by 2 dividing by n pi by 2 minus plus cos n pi x by 2 dividing by n pi by 2 whole square 0 to 2. We get this. This is 2 by n pi sin 0 0, then this cancel, this is also 0. These family members are 0. And 1 by 2, and putting upper limit, this is 2, here also 2, so 2 sin 2n pi by 2 by n pi by 2 plus cos 2n pi by 2 n pi by 2 whole square. We get this minus lower limit. Lower limit, this is 0. No, directly like 0 into something is 0. This is 0. And this is 0. Cos 0 is 1. This is 1 by n pi by 2 whole square we get. So this is our upper limit and lower limit putting, we get this one. So this is completely 0, then this is half we write, this is 0 plus half, this is 2 to cancel sin n pi is 0, this is directly 0, no need to write other term factor, directly 0. And this one 2 to cancel cos n pi means minus 1 to the power n, this is n pi by 2 whole square, and this one 1 by n pi by 2 whole square again. So this will be 1 by 2, and this is 4, n square pi square by 4. So this will be 4 by n square pi square minus 1 to the power n. Here also 4 by n square pi square. We get this one. And 4 by n square pi square common. N square pi square is common. Then this will be minus 1 to the power n minus 1 we get. So this will be 2 n square pi square we get, and this is minus 1 to the power n minus 1 we get. So here we get two conditions. If the power of n, if power of minus 1 is even, if it is even number, then suppose 2, then minus 1 to the power 2, then we get 2 minus minus 1 to the power 2 means plus 1, 1 minus 1 0. If n is even, then this result will be 0. If n is odd, suppose 3, then minus 1 to the power 3 is minus 1, minus 1, minus 1, minus 2, minus 2 and 2, 4. So we get two conditions. Here we have to write. So Bn, An equal to, we get two conditions. This is minus 4 by n square pi square if n is odd, and this will be 0 if n is even. We get two conditions. This line is clear. If this is even, if it is odd, then we get minus 1, minus 1, minus 1, minus 2, minus 2 and 2, minus 4, we get minus 4. And if it is even, minus 1 to the power 2, then plus 1, 1 minus 1, 0, then we get 0. So an equal to a not equal to 3, an equal to 0. Now we have to find bn. Bn equal to 1 by c minus c to c fx sin n pi x by c dx, and minus 2, c means 2, minus 2 to 2 fx sin this. Again we using the superheat formula. So superheat formula, minus 2 to 0 fx sin n pi x by 2 dx plus 0 to 2 fx sin n pi x by 2 dx. We get this one. So this will be 1 by 2 minus 2 to 0. If minus 2 to 0, then this is 2. 2 sin n pi x by 2 dx. And 0 to 2, if it is 0 to 2, then we get x. This is 0 to 2 x sin n pi x by 2 dx. We get this one. So we multiply half here, then 2 to cancel, and 2 to cancel, we get integration sign means minus cos. This will be minus cos n pi x by 2 dividing by n pi by 2, and this is minus 2 to 0. This one half multiplying here also using UV formula in one line formula. So x sign means minus cos n pi x by 2 dividing by n pi by 2 minus the dx of x is 1 and integration cos means sine. So this is sine n pi x by 2 dividing by n pi by 2, and this is n pi by 2, this is n pi by 2 whole square. We get this one, and this limit is 0 to 2 we get. Limit 0 to 2 we get. So this will be putting the upper limit cos 0 by n pi by 2, and if you putting 2, then we get cos minus 2 n pi by 2 by n pi by 2. We get this one, and here half remains same. Putting the upper, or we can write this is minus minus plus also. This is minus minus plus. Putting the upper limit is 2. So this is minus 2 cos 2 n pi by 2 by n pi by 2. This is sine n pi 2 by 2. This is n pi by 2 whole square minus lower limit, putting 0 here, this is 0, 0 into something is 0, sine 0, 0. These family members are 0. Directly we write the 0, 0. So cos 0 is 1. So this is 1 by n pi by 2. And these 2 cancel, n pi get cos minus n pi means plus cos n pi, and cos n pi means minus 1 to the power n. This is n pi by 2. We get this. And this one half remains same. And this is 2 cancel, n pi. N pi means minus 1 to the power n by n pi by 2. And this is 2 cancel sin n pi. Sin n pi is 0. So we get this. So this will be minus 2 by n pi. This is 2 by n pi minus 1 to the power n. These 2 cancel, 2 by n pi, 2 by n, these 2 cancel, 2 by n pi minus 1 to the power n we get. So we get this one. So this will be, so this is our this one, and this is minus this. So if we remove this bracket, 2 by n pi minus minus plus 2 by n pi minus 1 to the power n, 2 by n pi minus 1 to the power n. So this is minus, this is plus, cancel, we get 2 by n pi we get. This is our Bn. Now I want to write that Bn is here. Bn equal to we get minus 2 by n pi. This one. So we get a naught equal to 3, an equal to this, and bn equal to this. An equal to minus 4 by this. First we consider an equal to minus 4 by n square pi square if n is odd. If n odd, that putting here odd number, a1 minus 4 by 1 square pi square, this a3 minus 4 by 3 square pi square dot dot dot, and an equal to 0, that means if n is even, if n is even and even, so we putting a2 then 0, a4 then 0, so we get this, and so on. We can put in several values, and bn equal to minus 2 by n pi, b1 minus 2 by 1 pi, b2 minus 2 by 2 pi, b3 minus 2 by 3 pi dot dot dot. Therefore the Fourier series, by Fourier series we have, so by Fourier series we have f of x equal to a naught by 2 a1 cos pi x by c, a2 cos 2 pi x by c, a3 cos 3 pi x by 2 plus by c we get, this is c, this is our main formula, and b1 sin pi x by c, b2 sin 2 pi x by c, b3 sin 3 pi x by c dot dot dot. We get this, and putting the value a naught means we know a naught equal to 3 we get. So putting 3. So 3, this is a naught equal to 3. 3 by 2, a1. a1 means minus 4 by this. Minus 4 by 1 square pi square. We get this, and cos pi x c means 2. So this is a2. a2 means we know a2 is 0. 0 cos 2 pi x by 2. a3 means minus 4. Minus 4 by 3 square pi square cos 3 pi x by 2. So we get this plus dot dot dot. And b1 we know b1 means minus 2 by 1 pi. So this will be minus 2 by 1 pi sine pi x by 2, and b2 means minus 2 by 2 pi, minus 2 by 2 pi sine 2 pi x by 2, and b3 means minus 2 by 3 pi and sine 3 pi x by 2 plus dot dot dot. So at last we get f of x equal to 3 by 2. From this term 4 by pi square common. So this 0 is cancelled. So taking minus 4 by pi square common. So we get 1 by 1 square cos pi x by 2 plus 1 by 3 square cos 3 pi x by 2 plus dot dot dot. And here 2 by pi common. So minus 2 by pi common. Then 1 by 1 sine pi x by 2, and this is plus 1 by 2 sine 2 pi x by 2. So this one 2 by pi common, this minus also common, this, and 2 by pi common, minus common, this 3, 1 by 3 sine 3 pi x by 2 plus dot dot dot. So this is our required answer. Solution is long but not difficult. So this is the complete solution. F of x equal to this series we get. So this is our complete solution. Thanks.